Hello, everyone, and welcome to the Circuit Breaker PSC Ethereum Foundation Workshop, MACI Private Voting. Joining us today is Alex, who will be taking us through this session. And with that, I'll pass it over to Alex to get the session started.
Thanks, Rory. Hey guys, I'm Alex, or Control CO3 in the crypto world. Happy to have you here, guys. And so today we're gonna be talking about MACI, and this is a open source project from the PSC team within the Ethereum Foundation, and we do basically just ZK research, building apps or primitives. Yeah, let me see. Okay. Right, so we'll just quickly we'll go through what MACI is, why private voting is important, how MACI works, and what to build with it, which I think is what you guys are most interested with, and how to use it. If you have any questions, feel free to drop them in the chat, and I'll do my best to answer everything. Okay, so MACI stands for Minimal Anti-Collusion Infrastructure. And in a nutshell, it enables private polls. The main properties of MACI are collusion resistance. So only a coordinator, which is the entity running the poll, can be certain of the validity of a vote. You are not able to prove within any doubt how you voted, and that helps with preventing bribery. The privacy aspect is only yourself as a voter and the coordinator can decrypt a certain vote. Votes cannot be censored. Even the trusted coordinator, whether it's trusted or not, they won't be able to censor any of the votes that have been sent. Once you cast a vote, you cannot edit it or delete it, but you can nullify it. But no one else can do that for yourself. And finally, there is no way to produce false output by the coordinator. So why do we need private voting? So bribery is a very common problem in most protocols that do quadratic funding, quadratic voting, especially when, for instance, the quadratic funding, we have there is a financial incentive to bribe someone. And being a more democratic way of allocating, let's say, funds in the context of quadratic funding, people make a difference more than people with a lot of money. So the majority of people can vote for a project, and the result might be better than just one person with a lot of money coming there and voting more or putting more money into a pot. And in this case, if you can easily collude, then all of these funds might be misallocated. And in general, I would say as well that you can be easily influenced by people's opinion. So let's say you're voting for something and you see how other people are voting, that might affect the vote. So going back to the bribery problem is that with MACI, you cannot really prove how you voted. You could show to the briber, okay, yes, I voted for this option and I voted this, gave this vote, but they really have no way to verify that that vote is valid or neither that you casted another vote which overrides that vote. So in the end, why would they bribe you if there is no guarantee? And the goal is to have a more democratic approach and safe. In terms of the architecture, MACI is made of 3 different components, let's say. We have the smart contracts, which work on EVM-compatible chains. We have some circuits, which are used by the coordinator to generate proofs that the messages were processed correctly and all of the votes were tallied correctly. So the result of a poll is correct. And then we have some TypeScript utilities. For instance, we have a clone of the smart contract, which is used to replicate the state of chain and generate inputs for the ZK Snag circuits. We have a CLI, an SDK to interact with the protocol, and some of the primitives and TypeScript classes representing some of the objects you'd use to interact with MACI also reside in these TypeScript utilities. Okay, so how a user would use MACI? A user technically can do three things with MACI. A user can register, a user can vote, and finally, they can and should verify that the results are correct. In MACI, we don't identify users by their Ethereum address, even if all the voting happens on chain. We use what is called a MACI public key. You can see here, there's a public key and a private key, which is basically the public key is a point on an elliptic curve. In our case, the baby jump curve. And this is serialized, so that is easier to just easier to handle by users. And when you register, you will need to pass certain conditions. That's up to the person running the MACI instance. But let's forget about that for now. But in general, you register. So you send a smart contract transaction with your public key, and that's your identity. This identity is not tied to your address. So you are able to send votes, which we really call encrypted messages, and you can send that from anywhere. At the same time, anyone can send a vote, but only votes sent by people that register are going to be considered, on top, of course, of the validation that the vote is valid. So these votes are encrypted, which is one of the cool things about MACI. So you cannot see anything on chain. These are decrypted with a share key, which is generated using a random key and a coordinator public key. And when I talk about keys here, I'm referring to these MACI keys, so these points on the elliptic curve. Because we send this random key, public key, together with the message, the coordinator is able to reverse the process and generate the share key back to the decrypted. To prevent, of course, anyone from sending messages on your behalf, we do sign them using the MACI private key. Cool. So skipping ahead, we have all the processing, which I'll talk about later. And finally, the user will come take whatever was published by the coordinator, which is like the tally result, and they will verify on chain. So there's utilities to do that. So looking into votes, basically the vote, as mentioned, is an object. So in this object, we have the state index, which is basically the position in the Merkle tree of your sign up. You're given this when you sign up, so you will know that. There's your public key, there's the vote option, and the vote weight. So you can say, I'm voting for option 3, and I'm allocating 5 votes. By default, votes in MACI are quadratic voting. So basically, you are assigned a amount of voice credits, and that depends really on how you want it to be. It can be customized, but imagine where everyone has the same credits. Let's say you have 100 credits. You cast a vote using 5, a vote weight of 5, and that would be 25 because of the quadratic voting. Because of quadratic voting. And yeah, like there's a few other things inside, and nonce, which tracks the order of messages. And yeah, I talked about all that before. So we skip ahead, everyone votes, and then it's up to the coordinator to process all of these votes. So because we want users to save money when submitting a vote, we don't use normal Merkle trees on chain, but we use what is called an accumulator queue. So each sign up or message are added to this queue. And basically the difference with a normal Merkle tree is that you would not compute the root after each insertion, but that would be the job of the coordinator. So the gas cost for that would end up being on them. Fast forwarding, we copy the state of the smart contracts, and we start processing the messages. By we, I mean the coordinator, because they need their private key to be able to decrypt the messages using their private key and the ephemeral public key. Scanning through this, we generate zk-SNARK proofs, and then we submit them on chain. The coordinator cannot censor votes. So we talk about this. There is a number of messages being sent, the number of users that stand up, and all of that is recorded on chain. So if they try to submit data that is not valid, the proof will not validate, and users would not. Okay, so the trust assumptions are that there has to be a coordinator for now. We assume they are honest, but they can actually collude. So they could decrypt the messages and collude with bribers, or they could also decide to not finish a round. But what they cannot do is they cannot censor, and that's thanks to the smart contracts. And they cannot perform incorrect processing, and that is thanks to the zero knowledge part of MACI. The source of truth here is the smart contract. So the data is recorded on the smart contract, so there is no way to censor or publish wrong proofs. Yeah. In terms of challenges, if you do decide to build something on MACI, you probably figure out that MACI is quite a complex protocol and it can take some time to understand. We're working hard on improving developer experience, but that is not that's not perfect, but it's going in the right direction. As a user, you might find it a bit costly to use, and as a coordinator as well, some of the costs can be a bit high. Because of the zk-SNARK processing is done off chain, which kind of really is the beauty of it, but MACI is quite complex. So the circuit logic, it's complex, and the number of constraints of the circuits can be very large, depending on how many users you want to support, how many messages you want to allow, and how many projects you want to allow voters to vote for. So generating proofs can take a very long time. And finally, Sybil resistance is another problem, and that is true for every quadratic funding, quadratic voting protocol. And yeah, it would be great if contributors could try and integrate a protocol for like a proof of human protocol or some ways of gatekeeping users. And something to mention is, because we don't gatekeep who can vote, and of course these votes sent by someone that it's not registered will not be counted, but still they will account for space in the Merkle tree. So if there is enough financial incentive, someone might be able to spam the poll. So yeah, the most important part for you guys is what can you build? We're kind of open to anything really, and we like to see people experimenting. So there's quite a bit of quadratic funding application being built, so probably will not focus on that, but maybe like building a DAO voting app, so new ways to gatekeep users, better Sybil protection resistance, and even something as simple as building an app to privately vote on which movie to watch. Some front ends which you can use to balance round, so from the coordinator perspective, or some front end that you can use to contribute. You're free to pick any of these or discuss with us anything that you think makes sense to build. For instance, you could take some of the primitives like message encryption and just build something else. Why not? In terms of how the repo looks, we have a mono repo, so everything is in one repo. You probably won't need to touch the zk-SNARK circuits, but whatever is highlighted in blue is the TypeScript code. CLI is where the SDK resides. So there are commands which you can use to interact with MACI on a front end, or if you just want to interact with the CLI, you can do through there. Core is the copy of the smart contracts, which do the processing, and crypto and domain objects are some of the TypeScript utilities and classes that we use. Finally, the contracts is where you want to look if you need to implement some civil systems, some gatekeeping, and some new features. Okay, so I just wanted to walk through like a end-to-end usage of MACI. Won't go into too many details. A lot of this stuff is on our documentation website. And yeah, so because we use zero knowledge, we need, and we use the Graph 16 proving system, we need what is called the verification key. So we have two main circuits in MACI, the circuits that process the messages and the circuits that tallies the vote. For each of these circuits, we run a trusted setup, and we have a set of trusted proving keys, the Z key, as well as a set of verification keys. To be able to verify proofs on chain, you need the verification key. And so the first step of any MACI deployment is to deploy a registry holding these keys. In this contract, we're going to be storing this verification key. And then when the time comes to verify, the other smart contract will query it and use this to just verify the proof. Yeah, so the main part is then deploying MACI and all of the contract factories. If you do take a look at the contracts folder, you'll see that there are a few contracts. So we'll have the MACI one, which is where you go and sign up, and which manages polls. You have a poll contract, which is where you vote. You will have a message processor, which is the smart contract used by the coordinator to submit proofs and commitments to the data, and the tally votes, which is where the coordinator will submit proofs for the tally of the results, and user will go in to verify them. Some of the parameters are explained, well, all the parameters are explained in the documentation, but here when you deploy MACI, you can set the state tree depth, which is basically saying how deep is the Merkle tree holding the signups. A depth of 10 with a quinary Merkle tree, so 5 leaves per node, will be roughly 1 million maybe signups, which is a lot. So yeah, this deployment of MACI in this example will support 1 million voters. Okay, so after we deploy MACI, we can deploy a poll. Here you need to specify the public key of the coordinator. You can also generate these keys using the CLI, just like a gen MACI key utility that does that for you. And together with this key, we also say how long we want the poll to run and some of the other parameters like how many messages are allowed. In this case, by saying 2, we're only allowing 5 to the power of 2, so 25 messages. But again, all of this is explained in our docs. Okay, cool. So the user part, sign up. You as a user come, send your public key from whatever Ethereum address in this case, because we allow anyone to sign up in this test. You are given the state index. If you remember before, that was useful for creating a message. So with this publish command, we use the user public and private keys, the state index, and the nonce, which we start from 1, and then the vote weight and the option index. As you see on chain, basically the data is just, aside from the first part, which is just the message type, which is 1, everything else is encrypted, so no one really can see what's there. Yeah, so let's again imagine 10, 20 users sign up. There are 50 votes being casted and whatnot. The poll finishes. here as the coordinator will do the merging of the trees, as we said before, and they will generate the proofs. The output of this is this file, which is just a JSON file which holds the result. I kind of closed here the tally, but that's where you will see for each of the vote options. So let's say there were 20 projects, you will see how many votes each project got, which is like the sum of the individual votes, the valid ones. The total spent voice credits, so how many voice credits in total were spent by the voters, and how many were spent per each option. So this should be published by coordinator, and user can just submit it on chain and see whether this verifies or not. And yeah, they can do this using the CLI again. Just call verify, say which polity you're trying to verify, and pass this. Here we're basically verifying that the commitment, so like the Merkle root of the message tree, of the state tree, which all the sign up is correct, and all of the calculation were correct, and this cannot be fooled. Okay, right, so to conclude with, we believe that private voting is very important, especially when everything is going digital nowadays. And we think MACI can help make this more secure, but we need the help of you, whether you decide to participate in the hackathon building something on MACI, or you feel at some point to come to our GitHub or Discord and try to do some open source contributions. Everything we build at PSC is open source, as we believe that's the way to go. And it's just great to be building in public, getting the feedback from you guys, and being able to make something better, and hoping this helps someone at some point. Yeah, I'm sure the presentation slides will be shared, so there will be this link and QR to join the Discord. We have a public channel where you can discuss all things about MACI or other PSC projects. And here there's some useful links, like our documentation website, the repo, CLR Fund, which is a quadratic funding protocol built on top of MACI, and that is built by an external team. The demo code, which is what I showed in the end-to-end examples. Yeah, just some of the project ideas which we discussed today, and some posts by Vitalik, which is one of the original ideator of MACI. Yeah, I think that's kind of everything I want to say, and if you have any questions, you can ask now, or we can talk on Discord.
Awesome. Cheers. Thank you, Alex. Yeah, if anybody has any questions, feel free to type them in the chat or take yourself off mute and you can ask Alex here directly. Katya asks, how can we get these links?
I can share the presentation in Discord, maybe in the if global. Is that right?
Yeah, that's fine. Yeah.
Sweet.
Yeah, and for those hackers, if you haven't already, please connect your hacker dashboard to Discord so you can access the partner specific channels. And the question, is there a track for MACI? I believe there is, yeah.
Yes. So as PSC, we have 5 projects actually. So yeah, MACI is one of them, and it's one prize for one project. Yeah, and some of the stuff we don't. Where is it? Here. Or feel free to just propose anything. Yeah.
Yeah, and I just sent a link for the PSC prizes page as well, so you should see all that. Okay, we got it.
Nice, thank you.
Do we have any other questions? I guess, Alex, did you share what your Discord? Are you going to be answering questions in Discord channel as well, or is that mostly going to be Vivian or?
I'll be there.
Okay.
I'll turn notification on actually. Always disabled for Discord stuff. But yeah, it's Control C or free there, same way here. So just ping me there or whatnot.
Okay.
I'll answer. Yeah.
Yeah, I imagine you're gonna get quite a few questions, especially for this event.
Yeah. Looking forward to that.
Yeah, for the workshop, does anybody else have any other questions? And if not, awesome. Well, cheers, Alex. Thank you for the great presentation on MACI, and
Nice.
thank you all hackers for attending as well. So as a
Cheers.
reminder,
Thanks, guys.
hacking begins tomorrow. And yeah, Alex and the team will be on Discord. So if you have any questions, feel free to ask them in the partner PSE channel. So cheers.
Awesome.
Thank y'all. Have a good
Thanks,
rest of your
guys.
day.
Bye.